For the very first time, we have a new industry, a new factory, producing something brand new we call artificial intelligence.
NVIDIA is going all in on humanoids. They want to normalize autonomous robots in everyday life, at the office, in industry, and at home. According to the Wall Street Journal, the tech giant is developing a new Jetson Thor computer tailored specifically for humanoid robotics. The computers will be available during the first half of the year, according to the journal. Jetson Thor is based on NVIDIA's Thor system on a chip, which is a powerful type of computer chip designed to help robots make quick decisions, understand their surroundings, and interact naturally with people. The computers will be the newest addition to NVIDIA's Jetson platform, which began as a way to power AI tasks in small devices like drones and smart cameras. It's evolved to handle heavy processing work that once required large computers. This helps robots become smarter and quicker in real-time scenarios without needing constant cloud connections. The Wall Street Journal reports that NVIDIA's goal is to support a myriad of robot manufacturers through technology, not by building its own robots. This is similar to how Google provides its Android software for various smartphone makers. Meanwhile, Softbank plans to use NVIDIA's new powerful Blackwell chips to boost Japan's robotics and AI sectors. Softbank Chief Executive Masayoshi Son shared his vision during NVIDIA's AI Summit in Tokyo.
For the future of AI in Japan, what do you hope? What is your dream?
Well, look, as you say, I am passionate about AI robotics. I think we have to revive this passion with the robotics, bring the AI, as you say, bring AI intelligence into the robotics.
As the first company with access to the chips, Softbank plans to build a supercomputer to support research in generative AI.
Him to show the world that he hasn't lost his touch. Also raising the question, why Softbank and Masa-san and not an OpenAI or a Google who are at the forefront of LLM advancements? A source tells me it was simple. Softbank's order was early and it was large.
Softbank and NVIDIA are also working together on a network combining AI with 5G for faster internet connectivity to help robots and devices perform better in real time. NVIDIA has slowly established its footing in robotics over the years.
That will only get better from here.
Brett Adcock is CEO of Figure, a Silicon Valley startup with funding from NVIDIA. Look at his answer to labor shortages, an NVIDIA GPU-driven prototype called Figure 1.
Could you do this without NVIDIA's technology? We think they're arguably the best in the world at this. I don't know if this would be possible without them.
Jensen Huang founded NVIDIA in Silicon Valley back in 1993 in response to rising demand for high-performance graphics for more realistic video games and multimedia. NVIDIA launched its first graphics processing unit, the GeForce 256, in 1999. Its high-performance, real-time rendering laid the groundwork for NVIDIA's expansion beyond gaming. In 2006, NVIDIA introduced CUDA, short for Compute Unified Device Architecture. It was notable for enabling GPUs to perform general-purpose computing, so NVIDIA chips could be used for scientific, engineering, and artificial intelligence applications. By 2011, NVIDIA used its GPUs to accelerate training for AI models, essential for real-time data processing and decision-making in robotics. The 2015 launch of the Jetson platform marked NVIDIA's entry into robotics. Throughout the late 2010s, NVIDIA's tech became the hardware of choice for training large AI models. More and more robotics firms adopted NVIDIA hardware to train and run AI for autonomous systems, including humanoid robots. In 2022, NVIDIA launched its Isaac Robotics platform, which includes the widely used Isaac Sim simulator for robot development. Earlier this year, NVIDIA unveiled its Project Groot, an initiative for developing a general-purpose foundational model for humanoid robots. The project uses NVIDIA's tech to teach robots how to move and interpret human language. A robotics startup could use the foundational model with its hardware as a starting point. Since the model already knows a lot, the startup can focus on teaching the robot to perform tasks that can't yet be automated. NVIDIA says robots can learn a year's worth of data in under an hour with the tech giant's new AI model for accelerating the mass deployment of humanoid robots. In a new paper, researchers explain how the Hover neural network helps robots handle diverse tasks within one system. Hover teaches robots to do things like walk, pick up objects and move precisely without needing special training for each task. It uses a so-called policy distillation method that teaches robots skills by helping robots perform in a smooth, human-like manner. The team used Unitree's full-sized, general-purpose humanoid robot, the H1, to test Hover's abilities in real-world settings. The H1 was tested on tasks requiring motion tracking like standing, walking, and balancing. The researchers say the model helped the robot handle varied tasks accurately. It demonstrated significant efficiency gains in learning speed and task adaptation. The policy distillation method enabled the H1 to transfer learned movements to new tasks without retraining. Hover, accessed through NVIDIA's Isaac platform, has 1.5 million parameters to power rapid, complex learning for robots. With Isaac's simulator tool, robots learn skills quickly by practicing thousands of movements in a virtual world. The model instantly adapts to different robots, cutting down on time and cost by skipping extra training. Hover links with vision language models to turn instructions into quick, precise movements. Companies like Agility Robotics, Figure AI, Boston Dynamics, 1X Technologies, Fourier, Sanctuary, Neura Robotics, and Robot Era use the Isaac platform for their humanoid robots. In his keynote at AI Summit India, NVIDIA founder Jetson Thor broke down the company's approach to bringing AI into physical reality.
That next generation of AI needs to understand the physical world. We call it physical AI. In order to create physical AI, we need 3 computers, and we created 3 computers to do so. The DGX computer, which Blackwell, for example, is a reference design, an architecture to create things like DGX computers for training the model. That model needs a place to be refined. It needs a place to learn. It needs the place to apply its physical capability, its robotics capability. We call that Omniverse, a virtual world that obeys the laws of physics, where robots can learn to be robots. And then when you're done with the training of it, that AI model could then run in the actual robotic system. That robotic system could be a car, it could be a robot, it could be it could be a autonomous moving robot, it could be a picking arm, it could be an entire factory or an entire warehouse that's robotic.
NVIDIA has a suite of tools specifically aimed at expediting the production of humanoids. NVIDIA says its NIM microservices can reduce robot deployment times from weeks to minutes. The Mimic Gen NIM microservice creates synthetic motion data, while the Robocasa NIM microservice makes simulation-ready environments. Osmo, NVIDIA's cloud-based service, simplifies robot training and simulation. The company says it cuts development times from months to under a week. Teleoperation, which captures human actions to train robots, can be done faster and cheaper with NVIDIA's AI and Omniverse digital twin tools. The software is compatible with the Apple Vision Pro, which captures human demonstrations that are simulated and expanded into large datasets for training robots. NVIDIA has been vocal about humanoid robots, investing heavily in their development and capabilities.
Humanoid robotics will be as common as cars are today. You got to imagine what a car looks like 100 years ago on the street. What a strange instrument going down the street by itself without a horse in front of it. And so I think 100 years from now, it's very clear we'll have humanoid robots everywhere. It will likely be the largest volume mechanical system the world makes.
Remember to subscribe to stay up to date as humanoid robots take over the world.